If you had epilepsy 100 years ago, what kind of treatment do you think you would have received?
Today, we will explore the history of anti-epileptic drugs and learn how they work together. In ancient Greece, epilepsy was believed to be a sacred disease. People thought it was caused by the gods. However, around 400 BCE, Hippocrates, the father of medicine, pointed out that epilepsy was actually a brain disorder. But it took nearly 2,000 years before this idea was widely accepted. Even in the 19th century, there was still no proper treatment for epilepsy. People tried fasting, arsenic, and mercury, but none of these methods were effective. Finally, a breakthrough came. In 1912, in Germany, phenobarbital was introduced. This was a shocking discovery for the medical world. We can control epileptic seizures. Doctors were amazed. Some even called it a miracle drug. However, there was a problem. The side effects were strong. Some patients became so drowsy that they could barely move. Still, phenobarbital is the oldest anti-epileptic drug still in use today. So, how does this drug control seizures? The key is simple. Phenobarbital presses the brain's brakes. What are the brain's brakes?
The brain works by balancing excitement and inhibition. In epilepsy, excitement becomes too strong, causing an electrical storm, a seizure.
Phenobarbital helps by enhancing GABA, the brain's natural braking system. GABA attaches to GABA receptors, which calm the brain down. Phenobarbital directly boosts these receptors, making the brakes even stronger. This stops the brain from overfiring and causing seizures. Next, let's talk about valproic acid. Unlike phenobarbital, this drug was discovered completely by accident. In 1962, in France, a scientist was conducting a chemical experiment. Suddenly, he realized something shocking. I can't believe it. This liquid has anti-epileptic properties. So, how does valproic acid control seizures? It actually has a double block strategy. As we saw earlier, epilepsy happens when brain excitement becomes too strong. Neurons communicate by sending electrical signals. When a neuron receives excitement from another cell, it also becomes excited. Then, it passes that excitement to other neurons. If other neurons become too excited, there is a system to calm them down. But in epilepsy, this signal becomes too intense and out of control. Valproic acid works in two ways. First, it prevents neurons from becoming overexcited. Second, it boosts the brain's braking system. This braking system is the same GABA system we mentioned earlier. By stopping GABA from breaking down, valproic acid increases its effects, allowing the brain to calm down even more. This two-step action makes valproic acid extremely effective at preventing seizures. Over the years, new anti-epileptic drugs have been developed, and even some old drugs were found to be useful for epilepsy. Every anti-epileptic drug works in one of two ways, including reducing brain excitement and enhancing GABA's inhibitory effects. Now, let's take a closer look at how these drugs work. When excitement reaches a neuron, a switch is turned on, activating the cell. Inside the cell, small vesicles are already prepared, each containing glutamate. When the cell becomes excited, fuel is added, and the glutamate is released. Glutamate is an excitatory neurotransmitter, meaning it helps pass signals that increase activity in the brain. Glutamate attaches to receptors on the next neuron, spreading the excitement further. But different drugs intervene at different points in this process. Carbamazepine turns off the neuron's excitement switch and stops the chain reaction. Gabapentin reduces the fuel supply, making it harder for the neuron to stay excited.
Levetiracetam is a new type of epilepsy medication. It was developed in the late 1980s, but at first scientists had no idea how it worked. Determined to solve the mystery, researchers conducted extensive studies, and finally made a breakthrough. This drug was targeting an unknown protein hidden inside synaptic vesicles in the brain. This protein was later named SV2A, and it turned out to be the key to controlling the release of neurotransmitters. Levetiracetam binds to SV2A and regulates the release of glutamate, an excitatory neurotransmitter. By doing this, it helps prevent seizures.
Epilepsy was a mysterious disease for a long time, and treating it was extremely difficult. However, pioneers in medicine never gave up. Today, treatments not only stop seizures, but also help prevent them, and they continue to improve. What is now the present will eventually become the past. In the future, even more effective and safer treatments may emerge. Quick, powerful review. This is the only channel. Don't forget to subscribe.